Today we discuss some of the miscellaneous examples. In that, the first problem we consider is prove that tan inverse of root x, which is equals to half into cos inverse of 1 minus x divided by 1 plus of x. For proving this result, so we have the LHS part and we have RHS part. I will consider the LHS part. Let tan inverse of root of x, which is equals to a. So I will assume the left hand side term as a. So which implies root of x value will be tan of a. So on squaring both sides, we observe the value as x is equals to tan square of a. That means here we have determined the value of x, and the value of x will be tan square of a. Now, to prove the required result, I will consider the RHS part. Consider RHS part. What is the RHS part we are observing? Half into cos inverse of 1 minus of x divided by 1 plus of x. Now, I will replace the term x as tan square of a. So, therefore, half into cos inverse of 1 minus tan square of a divided by 1 plus tan square of a. As we have discussed that 1 minus tan square a divided by 1 plus tan square a will be a multiple angle in terms of cos function, and the value will be cos of 2a. Therefore, I will consider 1 minus tan square a divided by 1 plus tan square a as cos of 2a. So, we know the property that cos inverse of cos of x will be x. Therefore, we will consider its value as 2a. Now, the term 2 that get cancels, it is equals to a. So, therefore, we consider a value as tan inverse of x as we have assumed. So, therefore, we will write its value will be equals to tan inverse of root of x. This is nothing but LHS part. This is how, if this problem is appeared in examination, so observe LHS part and RHS part. Consider any one term, particularly a single term which we observe in the given problem. Assume that term as a, determine the value of x, substitute the value of x in the given right side term, so we will get the LHS part. This is how we used to prove LHS part is equals to RHS part. Now, let us observe this problem. That is, the question is prove that cot inverse of square root of 1 plus sin x plus square root of 1 minus sin of x divided by square root of 1 plus sin of x minus square root of 1 minus sin of x, which is equals to x divided by 2. So, whenever we observe this problem, students need to remember the point that when we observe right side, suppose if we consider theta, it is nothing but angle. When we consider theta divided by 2, it is nothing but half angle or sub multiple angle. So, therefore, here we require to prove the result in terms of half angle. For proving half angle, so we have some results in half angle. That is, some of the formulas we used to observe in half angle. That is, 1 can be written as cos square of theta divided by 2 plus sin square theta divided by 2. And sin theta, the term sin theta can be written as 2 sin theta by 2 into cos of theta divided by 2 sin theta by 2 into cos of theta by 2. So, for this problem, so we require to use both the formulas for proving LHS part is equals to RHS part. Now, observe the given problem. I will consider the LHS part, that is cot inverse of we have root of 1 plus sine of x plus root of 1 minus sine of x whole divided by root of 1 plus sine of x minus root of 1 minus sine of x. Now I will replace the term 1 as, so 1 can be written as cos square of x by 2 plus sine square of x by 2 plus 2 sine x by 2 into cos of x divided by 2. Plus again we have a term that is cos square x by 2 plus sine square x by 2 minus 2 sine x by 2 into cos of x divided by 2. That is, we have replaced 1 as cos square x by 2 plus sine square x by 2, and then sin x as 2 sine x by 2 into cos of x by 2. So divided by, we have the same terms. One can be written as cos square x by 2 plus sine square x by 2 plus sin x. The term sin x can be written as 2 sin x by 2 into cos of x divided by 2 minus, once again we have the term cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 into cos of x divided by 2. Now when we observe this term, it is of the form a square, the first term is of the form a square plus b square plus 2ab. So we know that a square plus b square plus 2ab is nothing but a plus b whole square. Similarly, in another result we have a square plus b square. Here we have minus 2ab. Therefore we will replace the term as a minus b whole square. So these are the two results we consider for proving LHS part is equals to RHS part. Therefore I will consider the term cot inverse of this term can be considered as cos of x divided by 2 plus sine of x divided by 2 whole square plus this term can be considered as cos of x by 2 minus sine of x divided by 2 whole square whole divided by, once again we have the same terms, that is cos of x by 2 plus sine of x divided by 2 whole square minus, once again we have a square plus b square minus 2ab. This term can be written as cos of x divided by 2 minus sine of x divided by 2 whole square. Now square and square root term that get cancels. Here also square and square root term that get cancels. Square and square root term that get cancels. Square and then square root term that get cancels. Now we simplify the term which is in the brackets, that is cot inverse of, we will write the term as cos x by 2 plus sine of x divided by 2 plus cos of x divided by 2 minus sine of x divided by whole divided by. So we have the term cos x by 2 plus sine of x divided by 2 minus cos x by 2 plus sine of x divided by 2, because minus into minus will be plus. So now sin x by 2 in the numerator that get cancels. In the denominator cos x by 2 that get cancels. Therefore we have a result cos inverse of 2 cos of x divided by 2 whole divided by 2 sine of x divided by 2. Now the term 2 that get cancels. As we know that cos divided by sine, it is a quotient function. So whenever we have cos divided by sine, it is nothing but cot of x divided by 2. So therefore cot inverse of cot, the term that get cancels, that is the result, the term remaining here is x divided by 2. That is what we require to prove for this problem. Let us prove this result. 9 pi by 8 minus 9 by 4 sine inverse of 1 by 3 that is 9 pi by 8 minus 9 by 4 into sine inverse of 1 by 3. We require to prove that 9 by 4 sine inverse of 2 root 2 divided by 3. For proving this, we have two methods. Let us discuss the first, that is easier method. I will consider the LHS part. Given that towards left side we observe that 9 pi by 8 minus 9 by 4 sine inverse of 1 divided by 3. Okay, so I will consider 9 by 4 as the common factor, because here we have 9 by 4, here also we have 9 divided by 4. The term remaining here is pi divided by 2, as we know that 4 2 ja 8, so 9 pi by 8 will be the term. So therefore pi divided by 2 is the remaining term, minus, so I will write the term as sine inverse of 1 divided by 3. So observe the term 9 pi divided by 8 minus 9 by 4 sine inverse of 1 divided by 3. As we know that pi by 2 minus sine inverse will be cos inverse of 1 divided by 3. As we know that sine inverse of x plus cos inverse of x, which is equals to pi by 2. So when we consider sine inverse toward this side, pi by 2 minus sine inverse of x will be equals to cos inverse of x. Therefore here we have written the term pi by 2 minus sine inverse of x can be considered as cos inverse of 1 by 3. Now here we require to prove the result as result in terms of sine inverse. That is, we know the method of converting one trigonometric function in terms of another trigonometric function. So that is the concept we consider here. So I will consider this term as 9 by 4 times of a, and I will consider this equation as star, where a is equals to, here a is equals to cos inverse of 1 divided by 3. What does it implies? It implies cos of a value will be 1 by 3. So we know that, what is the result we know here? When we require to determine cos in terms of sine, we consider a result. Sine a can be written as root of 1 minus cos square of a. Already students will be knowing this from the standard identities. Sine a can be considered as square root of 1 minus cos square a. Therefore I will consider sine of a, which is equals to root of 1 minus cos square a. What is cos square a? 1 divided by 9. So 9 will be the LCM. So 9 minus of 1, which is equals to 8 divided by 9. As we know that square root of 8 divided by square root of 9 is nothing but 3. Root of 8 can be written as 2 root 2 divided by 3. Because of the reason root 8 can be written as 4 into 2. Students need to remember this point. Whenever we observe square root of 8, the term square root of 8 can be considered as 2 root of 2. So therefore here we used to write the value of a as sine inverse of 2 root 2 divided by 3. What is the value of a we have assumed? We have assumed the value of a as cos inverse of 1 by 3. So cos inverse of 1 by 3 is nothing but sine inverse of 2 root 2 divided by 3. Now we will replace cos inverse of 1 by 3 as a sine inverse of 2 root 2 divided by 3 in the equation star. So therefore we observe that, which is equals to 9 by 4. Here we have in equation star we have written the value as a, but the value of a is sine inverse of 2 root 2 divided by 3. That is, we have replaced the value of a as a sine inverse of 2 root 2 divided by 3. And this is what we require to prove towards right side. So for proving this result, consider 9 by 4 as the common factor and use the identity, that is pi by 2 minus sine inverse can be considered as cos inverse. Convert cos inverse in terms of sine inverse by using standard identity. This is how we used to prove this result.